moving on, this is such a great section. 7.3 and 7.4 are so good, especially for placement tests. In 7.3, the variable is in the numerator. We had to find a common denominator with all of the three terms, typically 2 or 3 terms. 2 terms, you would cross product. 3 terms, we're trying to cancel out the denominator, and it's relatively simple to find the greatest common multiple, or least common multiple, of those denominators. And we're going to continue to do that. Just because there's a variable doesn't change anything. It should still be relatively simple. We're looking at each of these denominators, x, 4, and 4, and we see that the LCM, or at least common denominator, is 4x. And we're going to distribute it to each of the terms. And what ends up happening is it gets rid of all these denominators. So we see that we end up with this equation. And then we solve for it. So that's our objective. That's what we're going to be doing. We're going to look at the denominators. We're going to multiply everything times 3x. And so we have 3x times 1/3 plus 3x times 11 over x equals 3x times 4. Each of those pieces are coming from here, 1/3. We have our 11 over x, excuse me, and then we have our 4. So we find that common denominator, and we're going to multiply it by everything. And the benefits of that is this is all going to cancel each of these denominators. So the 3 in this denominator is going to cancel with that, leaving us with x and 1, or x. The x in the denominator here is going to cancel, leaving us with 3 times 11, which is 33. And then equals, and no denominators, we're just going to multiply 3x times 4, which gives us 12x. We're going to move that x over. We get 33 equals 11x. Divide by 11. And a nice, easy x equals 3. If we wanted to check it, 1/3 over 11/3 equals 4. 1/3 plus 11/3 gives us 12/3, which equals 4. So checking is, you can do mental math. That's not necessary to plug it in. It's relatively easy. So we look at the denominators, x and 5. Common multiple of x and 5 is 5x. So we'll do 5x times 16 over x plus 5x over negative 3/5 equals 5x times 1. Denominators cancel. We're left with 5 times 16, which is 80. This time the 5 cancels, and we're left with x and negative 3. So that's negative 3x equals 5x. We're going to add 3x to both sides. And this is why it's so important to be efficient with solving two-step equations, because this shouldn't be the thing hanging us up. We should be able to really be moving swiftly and confidently through that process. So we get this problem, and we're seeing, we're seeing some of the easy similarities between the problems now. We're seeing how things continue to work through the denominators. The 2's cancel, you're left with x. The x cancels, you're left with 6. And then 4x minus x minus x, 6 equals 3x. Divide by 3. 2 equals x. Now we have 3 denominators, but notice 2 of those are the same, so we're going to, let's do this, move it over. We're going to multiply it by 6x. 6x times 1/6 plus 6x times 2 over x equals 6x times 5/6. Cancels, left with x. x's cancel, left with 12. 6 cancels, you're left with 5x. Minus x, 12 equals 4x. Divide by 4. 3 equals x. Now we have three different denominators. So we're looking at those, and we should be able to eyeball what the common is going to be 12y. So we're going to do 12y times 3 over y plus 12y over negative 1/4. Be careful of that negative. 12y times 1 over 12. Y's cancel. We're left with 36. We can show this. We'll show the y's canceling, left with 12 times 3, which is 36. We're going to cancel the 4 into the 12, which gives us 3y times negative 1, which is negative 3y, equals 12's cancel, left with y. We're going to add the 3y over. We have 36 equals 4y. Divide by 4. 9 equals y. These are great problems. Lots of repetition, lots of at-bats for us. 8x. And the more of these problems, the faster we will be when it's a timed assessment. And you think, oh, I got 3 of them correct. I did 2 of them. I'm done. I've got the first 5 correct. But it really is about the repetition, and you're not trying to do less here. You're trying to do more. You want to be super efficient. There's no number that you can do that will be satisfied. I mean, you should constantly be practicing these skills. Think about the skills that we're practicing and how important or how much you will continue to use these throughout the next 8 years of your mathematical career. You have high school. High school, whether you go into geometry or Algebra 1 again, or Algebra 2, or pre-calc, or calc, or trig, or statistics, all of these basic foundational skills will be asked of you, and you have to be proficient at it. You cannot be sort of looking at it and thinking. You should be able to react and, as I always say, attack. So doing 30 of these problems, 40 of these problems, how many problems are we going to do today? We're going to do 44. So doing 44 problems should not be intimidating, and it shouldn't be something that you aren't looking forward to. This practice, this repetition is going to be extremely beneficial. Whoops, minus 3x. And making sure the more familiar you are with this, the less chance of making a silly mistake. Now, watch, I'll make a silly mistake in the next problem, but so x, 2, and 3 gives us a common multiple of 6x. So 6x times 1 over x plus 6x times negative 1/2 equals 6x times negative 1/3. Lots of negatives in there. Be careful. X's cancel. Left with 6. 2 goes into 6. 2 is in the denominator. 6 is in the numerator. Hence why we are canceling it. That's negative 3x equals, and now we have x, yeah, right here, that's 2. We have negative 2x. So add 3x, add 3x. I feel like I made a mistake. We can check. So 1/6 minus 1/2, which is 3/6, which gives us 3/6 negative 2/6, which is negative 1/3. So that actually worked. And I checked mentally. Ooh, here's some good denominators here. So common denominator is going to be 4a. It is not 4a squared. Think about least common multiple, LCM of 2a is 2 times a is a, and 4 is 2 times 2. So circle what, well, let's do this. Circle what they have in common. So they have nothing in common across all of them, but then we have some similar amongst 2, and then we have the leftover, which is that. So my LCM is going to equal 2 times 2 times a, which is 4a. That's how we get it. Now, it's not beneficial to do that, meaning, okay, we can do this process in the beginning. This is for beginners. For beginners. Beginners. And so we are looking to move towards just eyeballing it in mental math. So we don't want to be doing prime factorization. That is just way too time consuming, too labor intensive. So we got to get to the point where we can just do this through looking at it and be able to mentally come up with the LCM. Let's start canceling. A's cancel, 2 cancels with the 4. We have 2 times 7 is 14. The A's are going to cancel, and we're left with negative, oh, look at that, negative 12 equals, the 4's cancel, and you're left with negative a. Making sure that I did that correctly. That is correct. We get 2 equals negative a multiplied by negative 1, and we get negative 2 equals a. That would be our answer. We can check it. 7 over 4 minus 3 over 2. 7 over 4 minus 3 over 2. Does that equal negative 1/4? Let's check it out. That's 6/4. Ooh. Ooh, hold on. Hold on. That's negative. That's 12. That's 2. That's 14. That's negative. Negative a. Oh, negative 2. Sorry. That's negative. Sorry. And this is positive. Sorry. That's negative 7/4. Yes. Okay. Good. I'm glad I checked. Equals negative 1/4. So negative 1/4 equals negative 1/4. This is my check. So that negative threw me for a loop. That makes it negative 7/4. And then that negative will cancel with the negative in the 2. Good. Here we go. This is another good one with lots of different denominators. That gives us 6n. So 6n times 3 over n plus 6n times negative 1/2 equals 6n over 6 over 3n. It really doesn't do us any good to simplify that. We can just leave it as 6. If you wanted to write 2 over n, write 2 over n. We're going to have to simplify at some point, but that might, well, I guess it would help you with your denominators. We're going to cancel the n's. You're left with 18. We're going to cancel the 2's, and that's 3. So that gives me negative 3n equals, n's cancel, 3 cancels with the 6 equals 12. Let's move the, no, let's not do that. Minus 18, negative 3n equals negative 6. Divide by negative 3, and we get n equals 2. 3 over 2 equals 2 over 2. 6 over 3 times 2 is 1, so 3 over 2 minus 1 over 2 over 2 is 1, 1. Yep, that worked. Number 11, let's see, we've got 6a would be a common denominator. 2, 3a plus 6a over 5 over 6 equals 6a over 3 over 2a. Let's just not cancel with color. We've got 4, 6's cancel plus 5a equals, A's cancel. 3 equals 9 minus 4. You get 5A equals 5. Divide by 5. A equals 1. That's good. Let's move that over. Common denominator again is 6A. 6A times 2 over A plus 6A times 3 over 2A equals 6A times 7 over 6. And this is where we get that efficiency, that speed, equals 7A. That's a 9, not an A. 7A. That's going to give us 21 equals 7A. Divide by 7. So we can do this problem in less than 30 seconds. And that's going to give you a huge advantage. Huge advantage at your school. All right, now, 2 different ways to tackle this problem. You see the same example. You see that we're finding the common denominators, and we're multiplying it by the LCM of that. Any binomial has to have our guy, Chewbacca. Or we can just do the cross product. So solution 2 just utilizes cross product, which I would advise you to do. That's just, it's so much easier, so much more efficient. And then in the directions, I think it says, hey, make sure, did I have to do that? Make sure, right, no solution. Okay, whoops. So I didn't check any of these solutions. So, oh yeah, none of them were 0. So we didn't have any solutions coming out to 0, but you can't have 0 as a denominator. So none of those produced 0. These might, because now we have binomials. So we're going to have to check. Let's use cross product. I'm always going to use cross product when there are only 2 terms, meaning the left side is equal, a single term is equal to another single term. So we have 6 times 4 minus x equals 5 times the quantity 6 minus x. 24 minus 6x equals 30 minus 5x. We'll move the 6x over to get a positive variable. We'll move the constants over on the same line because we can do that. We're pretty good at this, pretty efficient. That's going to give us negative 6 equals x. Now that's my solution. If I plug in negative 6 in here, does it create 0 in the denominator? It does not. That would give us 12 in the denominator. And it would give us 10 in the numerator. 10 over 12 equals, simplifies to 6. So my solution set is just going to be negative 6. So we will have to check each of our solutions. Actually, you don't have to check. We just want to check the denominator. So we will be checking to make sure the denominator does not become 0 when we plug our solution back in. So we have 1 times x minus 1 equals x plus 4. X minus 1 equals x plus 4. We get a very interesting situation already where this is a different one. Now this is no solution. And it's no solution because the variables canceled and we were provided a number statement that was false. Since this is false, my variables canceled and we end up with a false statement. We have an answer of no solution. There is no variable that we can plug in that would make the left side equal to 1, is really what that's saying. Let's again cross product. We're just going to go and you'll sort of listen in and see the similarities, what's happening each time. So we see why multiplying cross product is the easiest and most efficient method. Doing it any other way would sort of be, would just be adding. It would add more. So we get x equals negative 1. If I plug negative 1 in for x into the denominator, does this become 0? Nope. So we're good to go. I don't even have to check. I mean, yes, you could check. So that would give me 4 over 6, which, yes, simplifies to 2/3. We could mental math it, but my main concern is that that my solution is not an extraneous. I think the word is extraneous solution. Pretty sure that's the verbiage we use. Let's cross product. 3 is in the numerator on the left side. X minus 3 is in the denominator on the right. And we know that 3 is a fraction, would be 3 over 1. So we don't have to write that. We really just want to be writing this part. We know that 1 times that numerator on the right side just produces x minus 5. 3x minus 9 equals x minus 5. Let's move the variables to the left. We'll move the constants to the right, and we'll do it in one fell swoop. And we get 4 divided by 2, and x equals 2. Let's check. Oh, I didn't. Oh, good. Yeah, I'm okay. Oh, no, I didn't write that. We might want to write it in a solution set. So when we plug in 2, do we get 0? We're good. So 2 is my solution. We're going to cross product. And we get 5 times x equals 6 times x minus 1. 5x equals 6x minus 6. Well, now I'm going to do this. I'm going to add 6 over, and I'm going to subtract 5x. And I get 6 equals x. And if I plug 6 into the denominator, it does not make 0. So I get 6 over 5 if I eyeball it. Let's do this. Let's get rid of the denominators. So the common denominator would be 7 times n minus 2. So I'm going to show you why this is. So now I have to multiply each of those. So I'm doing 7n minus 2 times n over n minus 2 equals 7 times the quantity n minus 2 times 5 over 7. Look at all the writing we have to do. Way, way easier. So now we'll cancel the n minus 2 with the n minus 2, which leaves us with 7n equals, and then we'll cancel the 7 with the 7. I wanted red. We're going to cancel the 7 with the 7, and that leaves us with 5 times the quantity n minus 2. Now, notice if we had just done cross product, do you see what we end up with? 7n, 5 times the quantity n minus 2. So this line, this is just so overly complex, overcomplicated. There's really no reason to choose that technique. It's always technique 2, cross product, is going to be so much easier. It's easier, it's more efficient, it's faster. I guess that's what efficient means. And almost forgot the negative there. Divide by 2, n equals negative 5. Let's look at the denominators. 5 doesn't produce 0, so negative 5 is going to be our answer. Same thing, cross product. We have 2 times x plus 3 equals 5 times x. 2x plus 6 equals 5x. Minus 2x minus 2x, 6 equals 3x. Divide by 3, 2 equals x. And 2 doesn't give us 0, so 2 is our solution set. 3 times x plus 5 equals 2 times x. 3x plus 15 equals 2x. We'll subtract the 2x, subtract the 15, and we get x equals negative 15. Negative 15 doesn't make 0. So we end up with, negative 15 over negative 10, which simplifies to 3 over 2. Cross product, 2 times x minus 1 equals 1 times x plus 3, 2x minus 2, x plus 3, minus x plus 2 plus 2. We get x equals 5. Doesn't make, so I'm hoping that one of these, when we plug in, will zero out the denominator. We'll try. So that's over 1, 5x equals 4 times x minus 1. 5x equals 4x minus 4, minus 4x. You get an x equals negative 4. Does not zero it out. What I mean is, again, if we plug in negative 4, you get negative 5. So that doesn't make 0 in the denominator. I'm hoping at some point one of these problems will produce a value, a solution that gives you 0 in the denominator. I feel like we got to get there at some point. X equals negative 5. Nope, negative 5 is negative 15 minus 1 is negative 16, so 4 over negative 16 is 1/4. So that was a mental check for the solution. And that's how easy it is. I mean, that repetition, that familiarity also provides me the speed to check my solutions. Minus 3x, we're going to move the constant over in one line. So that gives us 2x equals 14 divided by 2. X equals 7. And 7 plus 3 does not give you 0 in the denominator. So that is okay. 8x equals 4 times x plus 3. 8x equals 4x plus 12. Oh, minus 4x, minus 4x. 4x equals 12 divided by 4. X equals 3. Nope, gives us 6 in the denominator, so that's fine. My solution is 3. 5x equals 3 times x plus 2. 5x equals 3x plus 6, minus 3x, minus 3x. 2x equals 6 divided by 2. X equals 3. 3, nope, still okay. Still a good solution. 2 times x plus 1 equals 3 times the quantity x plus 3. 2x plus 2, 3x plus 9, minus 2x, minus 9. Negative 7 equals x. Negative 7 doesn't give us a 0 value. That's okay. 3, I said 3, wrote 2 equals 2x minus 4. Ooh, this will be a good one, I think. 3x minus 6, maybe? Maybe? Minus 2x plus 6. We get x equals 2. Yes! How did I know? Now, if we plug in 2 to here, we get 2 minus 2, which gives us 0, and that cannot work. So there is, our answer here is no solution. No solution, even though we came up, and this is what we call extraneous. That's an extraneous solution. So mathematically, we're using tricks to, we're using cross product, we're using whatever to isolate the variable. And so math doesn't really understand. Math doesn't know that 0 can't be in the denominator, but we know fundamentally you can't have 2 parts if you don't have any pieces. That's what a fraction is, part over pieces. We can't have 2 cannot be the solution, so the answer in this one is no solution. Ooh, look at this one. Oh, that's a fun one. A squared plus A equals 2. Okay, I guess we should know because chapter 4, so here you go. This is our first quadratic equation. Minus 2 equals 0. We're going to utilize the 0 property. We're going to factor this. We can't isolate for the variable. So we're going to do, let's do, so is it set equal to 0? Yes. Is it in standard form? Yes. Is there a common factor? No. Is it a special case? Is it a binomial square? I would only check binomial square because there are 3 terms, and that's a no. I wouldn't need to do difference of squares because difference of squares is 2 terms. We have 3 terms here. So we have to do A times C. So A is 1, C is -2. Factors of -2 are 1 and 2. Signs are different. Bigger is positive. And we get 1. Is that my middle? Yes. So we're going to take this and we're going to do -a plus 2a minus 2 equals 0. These 2 values went here and here, -1 and +2. And now we're going to factor by grouping. We're going to group the first 2 and group the second 2. We can factor out an a, you get a minus 1. We're going to factor out a 2 and get a minus 1. I know I did it correctly because we have the same binomial. So we're going to factor out that a minus 1 and we're left with a plus 2. So you see the a plus 2. That's where that's coming from. Equals 0. So we know that one of these must be 0. We're using the 0 product rule. So we set each one equal to 0. And what we're asking is, hey, what value for a would make that equal to 0? And when we write a plus 2 equals 0, we're asking that same question. What value for a would make that 0? So we get a equals 1, and we get a equals -2. Now we still have to check for extraneous. Do either of those values make 0 in the denominator? It does not. So my solution for this problem, I'm actually going to have 2 solutions. So let's check. We're going to use this one. We're going to extend this little problem. We're going to check now. Let's copy and let's paste this down here. Paste it down here. And we're going to check our answer. Let's check in blue. Let's check our solutions. Check. So we're going to check when a is -2. So check -2 and 1. So -2 plus 1 over 2 equal 1 over -2. That's going to give us -1/2 equals 1 over -2, which checks. And then we're going to check 1. 1 plus 1 over 2 equal 1 over 1. 2 over 2 equal 1. 1 equals 1. And that checks. So both of those solutions are correct. -2 and 1. Well, I like that. All right, again, we're going to do a whole bunch more. X times 3 plus x equals 2x times 1. 3x plus x squared equals 2x. We're going to move, oh, this is a good one also. So we get this, and we get x plus x squared equals 0. Remember, I'm setting it equal to 0. And now, I'm going to rewrite it in standard form. Standard form. So that gives me x squared plus x equals 0. And now I'm going to look for a common factor. And I do. I have an x. And we get x plus 1 equals 0. So now we didn't have to do a times c. We turn this addition and subtraction into a multiplication, or the product of 2 things that equals 0. So we're going to set each one equal to 0. X equals 0 and x plus 1 equals 0. That's already solved. We'll subtract 1. We get x equals -1. So those are my 2 possible solutions. But what do we notice? If we plug in 0, notice 0 would be in the denominator, and we can't have 0 in the denominator. If we plug in 1, so this is extraneous. That's not how you spell extraneous. Extraneous. And if we plug in -1, does that make 0? No. So I only have one solution of those. Only one of them is viable solution. That's a great question. This is why I love this book. I love big ideas, but I do love Dolciani and her problems. Really, really good. Let's set it equal to 0. So you get a squared plus 2a minus 24 equals 0. It's in standard form. No, it is set equal to 0. It is in standard form. There isn't a common factor. It is not a special case because 24 is not a perfect square. And so we'll do a times c. A is 1, c is negative 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Negative, so the signs have to be different. And the bigger is positive because when I combine my outside and inside, I'm left over with positives. So they have to be different in order to get that negative. So this is going to give me my positive 2. So I'm going to use this to split up my middles. I'm going to turn this trinomial into a polynomial. So I take that negative 4 and I take that positive 6, and then I just bring down my a squared and negative 24. Now I'm going to factor by grouping. And we're going to factor out an a. We get a minus 4. I'm going to factor out a 6, and we get a minus 4. I did it correctly because I have a minus 4 as my binomial, and a plus 6 is what pulls out, is left over. I have a product that equals 0. I'm going to set each one equal to 0. I'm going to solve for a. I get a equals 4 as one of my solutions, possible solutions. And a equals negative 6 is my other possible solution. I'm going to look at the denominator, and neither of those values would produce a 0 in the denominator, so I will have 2 solutions. I always put my solutions in numerical order. Good. Wow, these are good. Oh, hey! Now we have to use method 1. So the common denominator is x times the quantity x minus 2. We can't separate that. That has to be seen as a binomial. They are stuck together. So I'm going to have x times the quantity x minus 2 times 1 over x plus x times x minus 2 times the quantity 3x over x minus 2 equals x times x minus 2 times 0. And we're going to multiply. That x is going to cancel out, and that leaves me with x minus 2 times 1, x minus 2 times 1, which is just x minus 2. My x minus 2 cancels, which leaves me with x times 3x, which is 3x squared equals, and no matter what I multiply, this times this is always going to equal 0. So I'm left with I'm going to put in standard form. Right, so let's do set equal to 0. And also standard form. Is there a common factor? No. So now I'm going to go to special case. No. And then my last one is going to be a times c. So a is 3, c is negative 2, which gives me negative 6. 1 and 6, 2 and 3. It's negative, so my signs have to be different. And my combination of outside and inside leaves me with, I know they're going to be, outside and inside are going to be opposite because my signs are opposite, so I need to have more positives than negative. I need more positives than negatives. This gives me 1. This is my middle. This is my middle term, 1. So I'm going to take 3x squared. I'm going to change positive x to negative 2x plus 3x. You see that if I simplified that, that produces that. Minus 2 equals 0. And now I'm going to factor by grouping. Group the first 2, group the second 2. This is a good one. Another good problem here. So looking at the first two, I can factor out an x. I get 3x minus 2. Looking at 3x minus 2, there's no common factor. So I'm going to factor out a positive 1, and I get 3x minus 2. And I see that I did it correctly, 3x minus 2. If I pull that out, I'm left with x plus 1 equals 0. I'm going to set each one equal to 0. 3x minus 2 equals 0. X plus 1 equals 0. Add 2. 3x equals 2. Divide by 3. And we get x equals 2/3 is one possible solution. Minus 1, x equals negative 1 as another possible solution. Now I have to look at the denominators. Does plugging in negative 1 create 0 in the denominator? No. Does plugging in 2/3 provide 0? No. So those are both viable. And those are the answers. Really good. So again, what is my common denominator? I'm going to multiply everything by that. So I have x times x plus 1 times 4 over x plus 1 plus x times the quantity x plus 1 times negative 1 over x equals x times x plus 1 times 1. Let's see what cancels. You're left with x times 4, which is 4x. You have x cancels with x. You're left with x plus 1 times negative 1. So it's negative 1 times x plus 1 equals, and then we have x times x plus 1. Okay, now let's simplify. So 4x minus x minus 1 equals x squared plus x. This gives me 3x minus 1 equals x squared plus x. I'm going to move everything to the right because I want my leading term to be positive. My highest term, x squared, needs to have a positive coefficient. And that's that. So this is good. So it's set equal to 0. It is in standard form. It doesn't have a common factor. And is it a special case? Yeah, it's a binomial square. Let's think about what binomial squares. It has 3 terms. Second sign is positive. First and third are perfect squares, which they are, perfect square. And then if I write this, if I make it a binomial square, we take the square root of the first, bring down that sign. Does a times b doubled equal negative 2x? Which it does. So this is a product, so this is really this. And we set each one equal to 0 again. We know that we're going to get the same answer because it's the same binomial. So adding 1, x equals 1. We know that we're going to get the same solution over here. X equals 1. Plugging in 1, does it equal 0? No. So I only have one solution. I wouldn't write 1 twice. You don't have to. In fact, it would be written incorrectly. Just tell me the solutions if you have the same solution. So we're going to cross product because we're back to 2 terms equaling each other. 12x minus 24 equals 2x plus 6. Let's minus the 2x. Let's add the 24. That is going to give me 10x equals 30. Divide by 10. And we get x equals, that's a horrible 3. That's an even worse 3. Not even worse. X equals 3. 3 doesn't produce a negative. So 3 is my only solution. It's interesting that they would go back to this. Not sure why they would go back to that technique, but okay. That was weird. Okay. Here's a fun little trick. We're going to rewrite this to find a common denominator a little bit easier. I'm going to rewrite this as negative x plus 1, and then I'm going to factor out a negative from this. I'm going to rewrite that, and it'll look like this. 2 over x plus 1 minus 1 equals 1 over negative x minus 1. Oh well, I thought that was going to be, oh, okay. And then I'm going to pull this negative and I'm going to bring it up there to the 1. So I'm going to do this. 2 over x plus 1 minus 1 equals negative 1 over x minus 1. So now I see what the common multiple is going to be x plus 1, x minus 1. I'm going to multiply everything by that. And if I distribute it to all three of the terms, whoop, whoop, whoop. So x plus 1 is going to cancel, so I'm left with 2 times x minus 1. The negative 1, we understand that this rewritten is going to be x squared minus 1. So we get x squared minus 1, and then that negative. And then the x minus 1 is going to cancel, and we're going to have negative 1 times x plus 1. So I sort of did some fast, and you should be able to do fast. That's going to be negative x squared plus 1 equals negative x minus 1. Well, this is a negative x squared, so I'm going to simplify first. Negative x squared plus 2x minus 1 equals negative x minus 1. I need my x squared to be positive. Minus 2x plus 1 plus 1. So I have 0 equals x squared minus 3x, and that's the constants cancel. I'm going to factor out an x, and I get that. I'm going to set each one equal to 0. X minus 3 equals 0, add 3, x equals 3. X equals 0. If x is 0, that doesn't make anything. 3 doesn't make it, so I get both of those as solutions. Those are my two solutions. So that's good. This is really good. There's nothing we can do, so we just have the quantity of y plus 3, quantity of y minus 3. And remember, that's going to give me y squared minus 9. And I don't simplify this because I wouldn't see the canceling when I multiply each one. So when I distribute this to this, the y plus 3 is going to cancel with the y plus 3, leaving me with 2 times the quantity y minus 3. If I did this times this value, I wouldn't see the canceling because you can't cancel addition and subtraction. So that's why we don't do this. The reason why I did this is for this value. And then we have negative, well, let's do this, negative 1. The y minus 3 cancels. Oh yeah, let's take that away. Let's take that away. So when I multiply this times this, the y minus 3 cancels, and you're left with negative 1. This negative 1 right here times this leftover y plus 3. Okay, and so those will be gone. And then we have to distribute this to the 1, and that'll just give me y squared minus 9. That's why I do that, because we know that it's 1 times these two values. Those are conjugates. Conjugates are going to produce y squared minus 9. So 2y minus 6 minus y minus 3 equals y squared minus 9. Let's simplify the left side. Y minus 9 equals y squared minus 9. We're going to move the y over. We're going to move the constant over. 0 equals y squared minus y. Factor out a y. You get y minus 1. Set each one equal to 0. Add 1, y equals 1. So we get 0 and 1. Do either of them make 0 in the denominator? Nope. So my solution is 0, 1. I have 2 solutions for this problem. All right, we still have probably about 4 more. Oh, I like this. This is nice. So I'm going to multiply each of those. That's going to give me 2 plus 3 times x minus 1 equals 4x. You should be able to distribute that and see that solution that easily. That's going to give me 3x minus 1 equals 4x. Let's minus 3x. And we get negative 1 equals x. If I plug in negative 1, does it cancel? No. So those are okay. So negative 1 is my only solution. We have 6m, and that's going to give me m times the quantity 3m plus 5. That's going to give me negative 3m times m equals 10 times 6. 3m squared plus 5m minus 3m squared equals 60. Let's simplify. Oh, 5m equals 60. The m squares cancel. Divide by 5, and m equals 12. That was a fun one. 12's okay, so 12 is my solution. Cool, okay. X times the quantity x plus 4. Do you see how fast I look at the denominators and notice and can tell what it's going to be? Ooh, this is good. X minus 3, x plus 4. And then we're going to get plus 1 times x plus 4. And then we're going to get x times x plus 1. All right. It's good. This is going to give me x squared plus x minus 12. That's why multiplying binomials, mental math, our FOIL fest helped us multiply those 2 binomials super quick. Plus x plus 4 equals x squared plus x. We're going to minus the x squared minus the x. Oh, no. Simplify. Simplify, Mr. Mac. X squared plus 2x minus 8 equals x squared plus x. Let's move the x squared. Let's move the x. Those will cancel. You're left with x minus 8 equals 0. Add 8. X equals 8 is my possible solution, and it does not make any, there are no extraneous. We have x times the quantity x plus 1. That's going to give me 4 times x minus x times x plus 1 equals x plus 1. 4x minus x squared minus x equals x plus 1. Negative x squared plus 3x equals x plus 1. We're going to move everything to the right side, set it equal to 0. Minus 3x, 0 equals x squared minus 2x plus 1. That's a binomial square. Hopefully you see that. And that's a visual. I mean, you should know your binomial squares. And we're going to set each one equal to 0. And that's how fast we should be doing these problems. I continue to tell you that. I'm going to continue to push for that familiarity and for that recognition. Let's look and see. 1 doesn't make anything, so I have 1 solution. You should be able to. Now we're going to see this situation again. So we should know that we can write this like this. And we'd rewrite this. I'm going to factor out a negative. And again, I'm familiar with it. I know what the technique is. I'm going to take this negative and move it up to the numerator. And I get n minus 1 plus 2 over 5 over n plus 1. So now I know what my common denominator is. N minus 1, n plus 1. I've done this so many times, I understand the tricks. What are we going to do? We need to remember that this is n squared minus 1. When are we going to use that? For this term, because there's no canceling in that. We're going to leave it like this for these other two terms because the denominators will cancel with one of those. So we're left with -3 times the quantity n plus 1 because the n minus 1 cancel. We're left with 2 times. We're not going to write n minus 1, n plus 1 because we know that we'd have to multiply that. And then that's going to be 5 times n minus 1. These are the things that you can do when you are familiar and you've done hundreds of them. Let's simplify. 2n minus 3n minus 5 equals 5n minus 5. Let's move them over. Minus 5n plus 5. 2n squared. 2n squared minus 8n. Ooh, I like that. Equals 0. Factor out a 2n. That's a new one. I like that. Now we set each one equal to 0. 2n equals 0. n minus 4 equals 0. Divide by 2. N still equals 0. Add 4. N equals 4. Check those solutions. That's okay. 0 is okay. And 4 is okay. So those are my two viable solutions, 0 and 4. These are really good. Last one. Okay, not hard. N times the quantity n minus 6. I like braces. The n's are going to cancel. You're left with n minus 2, n minus 6. The n's will cancel again. You're left with -1 times n minus 6. The n minus 6 will cancel, and you're left with n times the quantity n minus 3. That's n squared minus 8n plus 12 minus n plus 6 equals n squared minus 3n. We're going to simplify. N squared minus 9n plus 18 equals n squared minus 3n. We're going to move the n squares over. We're going to move the 3n over. And that gives us 6n plus 18 equals 0. Now this is just a two-step problem. 6n equals -18. That dictionary keeps getting in the way. Divide by 6, n equals -3. Check our denominators. That's okay. We get one solution. Boom. Hey, if you can walk away knowing this section, 7.3, 7.4, it's going to put you in a huge advantage. Knowing how to do these problems, these rational fractions, fractions with variables in the numerator, fractions with variables in the denominator, even when they are binomial, will be extremely beneficial to you and allow you to test out. You will be doing this in Algebra 2 also. You'll revisit this in the first couple of chapters of Algebra 2. So good luck.